In a previous video we discussed about GCD and LCM of two natural numbers. In this video we are going to talk about Euclid's algorithm to find the GCD. Alright, but before we go to the actual algorithm, let's make a simple observation. And the observation goes like this: if we've got A and B, two natural numbers, alright, so this symbol here means belongs, so A and B belong to the set of natural numbers, and D is the GCD of these two numbers, okay, and X and Y are two integers. That means that D divides, alright, so this vertical bar here means divides, alright, so D divides A times X plus B times Y. Alright, the proof of this observation is literally a two-line type proof. So I would suggest that the student eager to understand what's happening here should actually go ahead and prove this. Okay, if there's any problems proving this, just send me a message and I'll prove it in a short video. Alright, so again, D divides A times X plus B times Y. Okay, this is a simple, very simple observation that we need to write down before we actually start looking at the algorithm. All right. Now, here's how the algorithm goes. Okay. So we've got these two numbers A and B. So let's say we divide A by B. Okay. When we divide A by B, we get a quotient Q1, let's say, and the remainder R1. All right. So this is how you would write your division. But now this is easy to write. It's a little bit harder to manipulate in mathematical equations. So for this reason, let's remember how you used to check if a division is right. So you would have to check that A, which is here A, is equal to Q1 times B. So A is equal to Q1 times B plus R1 plus the remainder. So this is how you check that this division is right. Okay, so I'd rather write this relationship instead of this of a division like so. So I'm going to refer to this as the division of A by B if A is equal to Q1 times B plus R1, where R1 is less than B and greater than or equal to 0. All right. So now let's suppose that actually the remainder that we get here is not 0, because if the remainder is 0, we just figure out that B is actually the GCD of A and B. Okay, so if this remainder that we got here is not 0, let's divide B by R1. All right, so if you divide B now by R1, okay, what we get is a quotient Q2 and the remainder, let's call it R2. All right, so B is equal to Q2 times R1, so Q2 times R1 plus R2, where R2, this new remainder, is less than R1 because we just divided by R1. All right, so and we keep doing so, right? As long as this remainder, the latest remainder that we got, is not 0, let's divide the previous remainder by the latest remainder, and okay, like R1 divided by R2 is, so R1 is equal to Q3 times R2 plus R3, where this latest remainder is less than the previous remainder. All right, so okay, and in here I actually wrote what this division looks like at the kth stage of it. All right, so okay, I just if instead of 1 we write a k here, and we notice that 3 is 2 greater than 1, so I would have to write rk is equal to qk plus 2, right, because 3 is 2 greater than 1, times rk plus 1, again because here 2 is 1 greater than 1, so I would have to have here an index that's 1 greater than this index, plus rk plus 2, right? So this is only this division at the kth stage. All right, so as you can notice, so far we just have a bunch of divisions, nothing complicated. Really the complicated part is the notation, but we have to get over that and focus on ideas. Okay, not on numbers, not on notations, but rather on ideas. All right, so this is a division, but Okay, so now let's notice what's happening here. So we get our remainder, we said is not 0, so we keep doing the division. We get another remainder smaller than the first remainder, and then we keep doing the division, and then another remainder smaller than the previous one, and so on and so forth. So this sequence of remainders keeps going down, but they are all positive numbers. All right, positive natural numbers, they cannot keep going down forever. All right, so it's got to be the case that this process stops. And when is it that this process stops? Is when we actually get, okay, to divide rk plus 1, all right, by rk plus 2. So we get rk plus 1 is qk plus 3 times rk plus 2 plus 0. All right, so this process will stop when we get a remainder of 0. All right, so again, we have here a bunch of divisions, and we figure out slowly that, you know, the sequence of remainders that we get keeps going down, okay, but they're all positive numbers, so eventually we get this division with a remainder of 0. All right, so now pretty much this is the algorithm. Now let's see what this algorithm tells us. All right, and let's sort of scan this algorithm by going from the last relationship that we got up to the first one. All right, so when we look at this relationship here, okay, what I see is that qk plus 2, rk plus 2, which is this number here, divides rk plus 1. So let's write down, so rk plus 2 divides rk plus 1. Right, simply because rk plus 1 is qk plus 3 here times rk plus 2. Okay, now let's go back up to this relationship here. All right, so we've got rk plus 2 over to the right hand side of this equality, and rk plus 1, and we just proved that rk plus 2 divides rk plus 1. So over to the right hand side we can factor an rk plus 2 in between these two numbers. So what this means is that rk divides rk plus 2 divides rk, right? Because we can factor an rk plus 2 on here. So rk plus 2 will divide rk. Now if we even write the previous division, okay, the previous division looks like rk minus 1, so I'm going to decrease all these indices by 1, is equal to qk plus 1 times rk plus rk plus 1, right? Where 0 is less than equal to rk plus 1 is less than rk. All right, so far we proved that rk plus 2 divides both rk plus 1 and rk. So when we look at this division here, rk here has a divisor that's rk plus 2, and rk plus 1 has a divisor of rk plus 2. So over to the right hand side we can factor an rk plus 2. So which means that rk plus 2 divides rk plus 2 divides rk minus 1. All right, and we can see a very nice pattern developing here. So rk plus 2 divides rk plus 1, rk plus 2 divides rk plus 2 divides rk minus 1, and so on and so forth. As we can keep going up this chain, we'll figure out that, okay, eventually rk plus 2 will divide these two remainders, so it will divide r1. rk plus 2 will divide these two remainders, so it will divide b, right? So rk plus 2 divides b, and rk plus 1 divides b and divides r1, so rk plus 2 divides a. Well, look at these two relationships here. All right, so what we got is that rk plus 2 divides both a and b, so that means that rk plus 2 divides the GCD between a and b. It's a very, very nice relationship that we got by sort of scanning this sequence of divisions from bottom to top. All right, now how about we scan this set of divisions one more time, but this time from top to bottom. All right, so we're going to look at this relationship first. all right? But what we are going to do is this. I'm going to take Q1b from the right hand side over to the left hand side. So what we get is A minus Q1b is equal to R1. All right? How is this different from this? Well, if we move the Q1b over to the left hand side, okay, well, what we can notice is that we have A and B over to the left hand side of this equality, so we can factor their GCD, right? So we can factor their GCD, so this means that the GCD of A and B divides R1. All right? Now, very nice. Okay, let's go back to the second equality here and do the exact same thing as we did with the first one. Let's move on the Q2 times R1 over to the left hand side. So we get B minus Q2 times R1 is equal to R2. Now, if we examine the left hand side of this equality, all right, we figure out that okay, we have R1 and GCD of A and B divides R1. Obviously, GCD of A and B divides B. So what this means is that the GCD of A and B divides R2. Well, look at this. Okay, so here's a very, very nice relationship saying that the GCD of A and B divides R1, GCD of A and B divides R2. Right? So GCD divides both of these remainders. Well, guess what will happen if we actually do the exact same process for the third division here? Okay, so we are going to figure out that GCD of A and B will also divide R3 and so on and so forth, and eventually it will divide all these remainders, and so we are going to figure out that GCD of A and B divides the last remainder that's not 0, divides RK plus 2. All right? So, very, very nice. All right? So, well, here's what we got. On one hand, we've got here that the GCD of A and B divides RK plus 2. On the other hand, we got that RK plus 2 divides the GCD. So, basically, what we just proved is that the GCD, all right, let me squish it in here, that RK plus 2 is equal to GCD of A and B. And this is Euclid's algorithm, okay? So basically, this chain of divisions will lead us to this remainder. This is the key right here. And this remainder, the last remainder in this chain of divisions that's not 0, this is the GCD of A